So, good morning, everyone. We are going to discuss the very important inequality that is called the Cauchy-Schwarz inequality. The statement is that if even to n are n tuples, v1 to bn are n tuples, means or real number, then if you take square of summation of cross product ai bi, then it is less or equal to summation of ai square and summation of bi square. Or equivalently, if you take a square root of both sides, we can get the equation number. So now we come to the proof. How we deal with the proof? So to prove this theorem, we have to use one auxiliary results. What is the auxiliary result? Suppose there is a quadratic polynomial x square plus bx plus c, which is greater or equal to 0, and a is greater than 0. A means coefficient of x square. Then it's a discriminant, means b square minus 4ac is definitely less or equal to 0. This proof is quite obvious. So let's start with the, so let ax square plus bx plus c is greater or equal to, I have taken common a, so it first term remain x square, second term uh, b by a into x plus c by a, right? This is also greater or equal to, why? Because since a is greater than 0, we have taken common a in the left side, and this implied, now we try to make uh, this bracket term as a square of something. So we can write this as x plus b by twice a whole square. C by a is already earlier. To make balance, if you open this bracket, if you open this bracket, what you get? First term x square, this is clearly seen, plus second term is square, b square divided by 4a square. So to make it balance, we have to add, means here added, so here we subtract minus b square by 4a square, right? And next term is the 2 into x into b by 2. 2 cancel, x into b by a, which is already, so it is a balance, which is also greater or equal to 0. Yeah. So now, so here we take the LCM of the, I mean bracket second term. So here we get uh, if you take LCM, so first is term A, another is 4a square, so LCM is 4 square. So here first you get the 4ac minus b square, and I have taken minus common, then you can write the, you can take here is the minus b square minus 4ac. So earlier term, so see this whole is greater or equal to 0 when, since a is greater than 0, so this is greater than, since this is square of something greater than, this is greater, 4a square, this is also greater than 0. So here, if whole quantity become positive, if this bracket term become positive, means if we left negative, then this b square minus 4ac should be lesser equal to 0. So this should be lesser equal to 0. So this is the proof of the substitute result. Now we come to the proof of our main result. What is main result? So to prove main result, we have considered a polynomial of twice degree. Fx is equal to summation I is equal to n aix minus bi whole square. It is the sum of square of n term of quadratic degree. Clearly, since is great square of something, so it is greater or equal to 0. Whatever you take real. Now we expand this. So just use the simple formula a minus b square. So here a square minus 2ab plus b square. So summation is outside, so summation goes to the all the terms. So first term becomes the summation I is equal to 1 to n a square. Since it does not depend on x, so x square come outside. Similarly for second, 2x's come outside, and summation b ai bi, and last term is the summation bx square. See, uh, here you see, uh, our this term is greater or equal to 0, and we can treat this as a polynomial in x square. Polynomial in x square, right? So here coefficient of x square is this term, coefficient of x is this term, and last is the constant. As earlier we proved that this is greater or equal to 0 and coefficient of x square, this is also greater than, so its discriminant, so its discriminant is less than or equal to 0, which come in the next slide. So in the next slide you can see clearly whatever I had is this and see this. So a discriminant means b square minus 4ac. So you can say square b square is this or minus 4 into a into c, and by the previous result this b square minus should be greater or equal to 0, then only summation of polynomial of quadratic is greater or equal to 0. So if this is less or equal to 0 and we shift this term to, if we shift this term to right side, so we get, and cancel 4, so we get summation ai bi is less or equal to summation ai square into summation bi square. So now we finish the proof of this. In the literature, in the book, if you go, you can see a number of proof of that, but as per my experience, this is a very simple proof. So thank you very much for going my slides.